this is to review the other Kung Fu quiz to make sure you're ready for the solution. So first thing is, first answer, number one is B. We know that K varies with temperature. KSP, some values get larger, some values get smaller. To be honest with you, it's not like a set change in solubility. So what we do is we just know solids vary. The solubility of solids does vary with temperature changes. K always varies with temperature. Just keep that in mind. There's not a uniform one for KSP, so you don't have to worry about that. Next, in KSP expression, silver phosphate, remember it would be Ag3. PO4 is going to break into 3Ag plus PO4 3 minus. Solids aren't included in equilibrium expression, so what you're going to get is you're just going to have C would be your correct answer choice, Ag to the third, and PO4 to the first. Next one, they're telling you KSP. Now, they give you KSP, we have to do it without a calculator. Remember, nickel hydroxide is Ni parentheses OH parentheses 2. That's equal to 3 ions, right? So if you think about it, it's basically 4x cubed is equal to 1.6 times 10 to the negative 16th. Well, if we're going to solve this, the first thing we're going to do is we're going to divide by 4. When we divide by 4, it's the same thing as 4.0 times 10 to the 0 power. So we go to do that, like we go to figure that out, is I would move this over to make it simpler. So I would go, what's the 16th? Oops, I wrote it wrong. It's the 16th. So I basically move this over. So I basically do 4. 4 into 16 is going to be 4, right? And then I'm going to take, if I move that over this way, so when I do it, let me erase that. So basically what I'm doing is this. I have 4.0, no, again. I have 1.6 times 10 to the negative 16. I'm going to move this over to make it 16. Whenever I go to the right, the negative exponent is going to go to the 17th. So then basically what I'm going to do is I have 4x cubed is equal to that. So I'm going to divide by 4, which is 4.0 4 times 10 to the 0 power. 16 divided by 4 is going to be 4. And then negative 17 minus the 0 is going to be to the negative 17th. You can't do a cube root without a calculator, so what they would do is they would give you the simplified version of it. That's why A is the correct answer. You can use the scientific notation method to simplify it, but that's what you have to be able to do to score on that question. Next one, molar solubility. It's 3 ions, so 4x cubed is what they're asking you for. Now remember, on the AP exam, they could ask you the molar solubility or solubility of PB, which would be equal to x. I would be equal to 2x. Because remember, when it breaks up, you get PBI is going to break up into PB2 plus 2I minus. So this is x and 2x. And when I drop it all the way down, I get x and 2x. And then that's where, when I put it into the expression, this is to the first, this is to the second, that's where 4x cubed starts with. Remember, on the AP exam, you got to pay attention to the E line because the relationship is different. But in this case, they're just asking us x. So we're going to go 4 times 4x to the cubed is going to be equal to 3.2 times 10 to the negative 8. So the first thing I'm going to do is divide by 4. So we do that. I'm going to get 4.0 times 10 to the 0. So let's see. I'm going to just move this over, pop that over there. So I'm going to get 32 times 10 to the negative 9th to make it easier. So 32 divided by 4 is going to be 8. So I'm going to get 8 times 10 to the negative 9th. Now, when I go to take the cube root of this, the cube root of 8 I know is going to be 2, right? So I take the cube root of it, it's going to be 2. What I'm going to end up doing is I'm going to basically have this. I'm going to take the cube root of 9 basically is going to be to the 2 to the negative 3rd. So when you cube root that, basically it would be the cube root of 9. It would be simple. The cube root of 9 is 3. Wait. Yeah. Yeah, that's the correct answer. That's not that easy to do without a calculator, but I don't know if they would expect you to exactly do that. 5. Determine the solubility of lead 2 fluoride in a 0.004 solution. So remember, it's going to be PB F2 is going to break into PB2 plus 2F minus. Now, when they tell me it's lead nitrate solution, means this is 0.0040. This is going to be plus X. This is going to be plus 2X. And then ultimately, I'm going to get 0.004. And this is 2X. Then remember, I'm going to basically drop it into my expression. My expression is going to be PB to the first and F minus squared. So it's going to be 2X squared. This is going to be 0.004 equals 4.0 times 10 to the negative 8. So when I set that up, just remember it's like a fast problem. Think about it like this. Whenever I'm given a common ion, it's going to basically drop into the expression. This is more likely to be given to you on the free response. I doubt this would be a multiple choice question, but we'll look at the math anyway. This is going to end up being 4x cubed, right? And then this is going to be 4.0 times 10 to the negative third. So let's deal with that first. We'll divide over here. If we can try doing this first. 4.0 times 10 to the negative third. Simplify that first. It's going to be 1 times 10 to the negative, what's that, fifth. I'll get it there. And then I'm going to multiply that times 4, or actually, no, I'm going to divide that by 4. So then what I'm going to do after that is I'll have 1.0 times 10 to the negative fifth is equal to 4x squared. So I'm going to divide this by 4 is equal to x squared. So I'm going to have to take the square root of this. So when I go to take the square root of this, the square root of 4 I know is going to be 2. So really it's going to be equal to 1.0 times 10 to the negative fifth square root divided by 2. And 2 is your correct answer. Really it's going to be setup based, because without a calculator there's no way they can make you do that. Solubility of silver chloride, so they give me the solubility, they want to know the KSP, so they're asking that silver sulfide is going to be Ag2S, which is going to be 2Ag plus S2 minus, and they're telling us X. So when we go to do this, this would be, if they're telling you the solubility is this, that means this is 8.0 times 10 to the negative 17th. This is going to be double that, so that's going to be basically, I'm going to take this and double it. So this is going to be 1.6, or actually 16. We'll do, if we double it, it would be 16 times 10 to the negative 17. Actually, so it would be, oh, they're all the same, so you don't have to do the math. So this would be 16 times 10 to the negative 17th, double. 17th, and then this is going to be squared, so I'm looking for 8.0 times 10 to the negative 17th squared. Oh no, this is squared. Actually, this is squared because it's 2Ag. Because it's going to be Ag, concentration Ag squared, S2 minus to the first. So this is going to be squared, so I'm looking for, it's going to be C. C would be the correct answer. It's asking for the setup, because it starts with 8.0 times 10 to the negative 17th. We'll erase that, pretend that didn't happen. Actually, clear this whole thing out. So we'll do Ag, so we'd say this. We'd say Ag2S is going to break into 2Ag plus S2 minus. If this is 8.0 times 10 to the negative 17th, this would be 16 times 10 to the negative 17th, because I'm just going to double it, and that's what they have there. And then this, because when you put it in the expression, this is basically going to be, this is Ag squared. You drop it in, square that one, that's going to go in, and you get C. Next one, equal volumes are mixed, KSP for silver chloride when the two solutions are combined. So what's happening is they're asking us if a precipitate's going to form. Well, when they mix equal volumes, automatically one trick you want to remember is the molarity is automatically going to be cut in half. So instead of having 1.6 times 10 to the negative fifth, it's going to be half. So I'm going to basically end up with 8 times 10 to the negative fifth, what I would end up with. So I would end up with, actually no, it wouldn't be, it would be 0.8 is half of it. So 0.8, so I would do this. I would get 0.8 times 10 to the negative fifth for that one. Same molarity there, because you're basically asking for a Q. they're asking whether or not a precipitate will form. So you have to do Q 0.8 times 10 to the negative fifth. So when we go to do this, we're going to make it, to simplify this and do the calculation, what we're going to do is change it back into scientific notation. So I'm going to move it here. So both ion concentrations are going to be 8.0 or 8 to the negative 6 times 8.0 times 10 to the negative 6. What's 8 times 8? 64. And what's negative 6 plus negative 6? So my Q value when I do this, because remember Q is the same thing as KSP. It's solved the same way. I'm going to get to the negative 12 is what I'm going to get. But then when I move it back over, it would be 6.0 times 10, 6.4 times 10 to the negative 11. If you notice my KSP is larger, 1.6 is larger than 10 to the negative 10. So that means there's going to be no precipitate forming. B would be your correct answer, because it goes back to fundamentally what do we know about KSP problems. Like if you look here, if they're asking me one ion form, well, it would be Ag C alpha form. You'd have Ag plus Cl minus. Remember, when it's a precipitate, you do no ice table. So there's no ice tables, no ratios. All you're doing is the ions and throwing them in, and the equilibrium expression is going to be Ag plus and Cl minus. So what I do is, the trick is, when you take these, you're automatically going to have the polarities. That's where I got the 0.8 times 10 to the negative fifth, and then 0.8 times 10 to the negative fifth. And then what I do is pop it back over. This would be 6, pop it back over, 6, and then I do the calculations based on that. Does that make sense? Next, 8. 8, the correct answer is A. Solubility, it's 1.6 times 10 negative 11. They're asking you if it's metal 2 sulfide, means it would be basically x squared is equal to KSP, because it's 2 ions is what we're talking about. So what we're basically going to do is we're going to take the square root of 1.6 times 10 to the negative 11. Well, what's half of 1.6? I would switch it over, move it over here to make it easier. So I'm going to say 16 times 10 to the negative 12. Take the square root of that. 16, square root of 16 is going to be 4. Half of negative 12 is going to be times 10 to the negative 6. Manipulated in scientific notation makes it easier to deal with. Next one, calculate the pH with the KSP is this. Metal hydroxide, so notice the metal is basically, it was +1 charge, right? Because it's XOH minus, so it would be XOH breaks into X plus 1 plus OH minus. So ultimately, it's X squared is going to be equal to KSP, which is going to be 1.0 times 10 to the negative 8. So I take the square root of this. Well, the square root of 1 is going to be 1, and then half of 8 means I'm going to get 10 to the negative 4th. So I take half of the exponent, which means that I just solved X is molar solubility. So think of it like this. We think of it like a ice table. This would be plus X plus X. So this is basically 1.0 times 10 to the negative 4th for OH. To get pH, we take the OH concentration. The negative log of that is going to be 4. That's going to be my POH. That means my pH has to be 10 using the scientific notation trick. Next question. The correct answer is going to be B5. pH is 9. What does that mean? It means then if my pH is 9, that means my POH is 6. Actually, I lied. That's 5, actually. Pardon me. It's 5. So meaning 5, my POH is going to be 5.0. My POH is going to be 5. My POH. And then I can, if I want to change it back, it would be 1.0 times 10 to the negative 5th. Would give me my OH concentration, because that's what I need. So it's basically going to be XOH minus. It's going to break into X2 plus, because that's the metal ion. You can see the charge from that. Plus 2OH minus. So when I pop it in and I go in, it's asking me, calculate the KSP. So this is equal to 1.0 times 10 to the negative 5th, right? Well, this value is going to be half of that. So I'm going to end up with 0.5 times 10 to the negative 5th there. And then when I go to drop it in the expression to calculate KSP, what I'm going to do is this has to be squared. So we'll go 1.0 times 10 to the negative 5th squared. This is going to be, I'm going to move it back over here. So it's going to be 5.0 times 10 to the negative 6 to the first. So when we square this 1 squared, this is going to be, you double the exponent, so I'm going to get 1.0 times 10 to the negative 10th there. And then I'm going to multiply 1 times 5, I'm going to get 5. So when I look at my answer choices, I'm automatically going to eliminate C, D, and A. And then I'm going to look at, I'm going to add these together. I'm going to go 10 to the negative 6th and 10 to the negative 10th is going to give me 10 to the negative 16th. And just keep in mind, OH concentration, pH plus POH has to equal 14. So pH plus POH equals 14. So my pH is 9, my POH is 5. I can convert that into scientific notation. Just remember that OH is double. You got to pay attention to the ion concentrations on the AP exam. Those are all the KSP problems you need to know for the ones tomorrow. Make sure you look back at the solution ones we did in class, especially the gravimetrical analysis ones like 9, 10, and 11 we went over. I'll put the answers up. Review because it's a scoreable test, but you definitely have to practice. Have a good evening.